Hey, it's Mr. S here with another function family video. The function family we're going to be talking about today is actually the exponential function family. How do you tell? There's an x as the exponent, and the base I always like to safely put in parentheses. So basically I type this in my calculator, and this is how you type it in your calculator. You go to y equals, protect that base, 2. To access the exponent feature, hit the caret button, which is under clear, and hit X, and then right arrow out of it. And we're going to type this exponential function into our calculator, hit graph, take a look at it. Kind of looks like a J-shaped curve. And the table, of course. If you hit second graph, you get to the table. And the table, I kind of copied here a section of the table. After I graphed it, there's arrows on either ends of it. And as you can see, it slowly gets higher, and then all of a sudden it accelerates and gets higher that much faster. Now, here's the thing. As you can see from this table, and even from the table in your calculator, as you backtrack and go through the negative x's, you see how the y values get smaller and smaller and smaller, but you can never quite get to 0, because if you think about it, if you have a piece of paper, you cut it in half, and then cut that in half, and then cut that in half, you'll always have a little bit of paper left. You'll never get to 0 amount of paper. So there is really no x intercept here. It never quite reaches a y value of 0. And that line, the x-axis, which is the equation y equals 0, is serving as what's called an asymptote. An asymptote is a line that a curve gets close to without quite touching. It gets very close. I like to call this like a landing strip for the function, how it gets very, very close, kind of guides it in, but never quite touches, never quite gets there. The y-intercept clearly on the table, 0, 1. And of course, this would be what you see in a calculator if you graphed it. I like to put parentheses around my base. This is like the standard form, the parent function of an exponential function. There's a lead coefficient in front, which is acting as the y-intercept, usually. There's some cases where it's not. You could always look at the y-intercept on your calculator, though, so that shouldn't be an issue. The base always has to be larger than 0. Can't have a negative base. So that's kind of like the general formula that we're going to be talking about. Now, if I type in y equals 3 to the x, now 2 to the x, you were kind of doubling. If you look back at your table, you're doubling each time the y values. Now the y values will be tripling. So as you can see, they get that higher that much quicker. So the y values get larger quicker compared to when the base is 2. So if you increase the base, you're obviously going to increase those y values faster and faster. Kind of like with 5 to the x. 5 is a base that's bigger than even 3, so it's going to quintuple. All those y values get quintuple if you type them into your calculator. The y values get even larger quicker, so I'm going to type that in, kind of like use it as my parent function. 5 to the x. This is what it looks like. Notice it gets that much higher, that much quicker. Now, if I wanted to type in negative 5 to the x and see what that negative in front of the function results in, take a look. But I'm sure by now you guys know if the negative's in front, it reflects across the x-axis, as you can see with that red exponential curve. And of course, you might not know this one. What if I took the reciprocal of 5 and put 1/5 in instead? What happens when you take the reciprocal of the base? Well, it reflected it across the y-axis. So when you have that reciprocal in there, it reflects across the y, and if you have a negative in front, it reflects across the x. And I'm going to take a brief break, and I'm going to come out with video part 2.